we completed one unit. In that we come across so many equations. The equations which we find out average velocity, that is V average is equal to U plus V by 2. Then acceleration A is equal to change in velocity by time. Then we come across the equation V equal to U plus AT. Then S equal to U T plus half A T square. Then 2AS equal to V square minus U square. These three equations for uniformly accelerated motion. Then graph such as distance time, velocity time graph of uniformly accelerated motion. Then about circular motion, V is equal to 2 pi r divided by t. These are the equations we come across from this unit motion. Now to finish this unit, we want to do some exercise problems with these equations. Among that, first one we did in the previous class. Now second question is that Joseph jogs from one end A to other end B of a straight 300-meter road in 2 minutes 30 seconds. That means on straight road from A to B, this distance is 300 meter and he took 2 minutes and 30 seconds. He took this much time to jog from A to B. It is a straight road. Then turns around and jogs 100 meter back to C. Then he jogs 100 meter back to C. 100 meter back to C, and the time taken for it is 1 minute. Time taken for that 1 minute. Now we want to find Joseph's average speeds and velocity in jogging from A to B and from A to C. From A to B and A to C. First of all, we can find out the average speed from A to B. We know average speed is equal to, that is V average is equal to total distance by total time. What is the relation? To find average speed, V average is equal to total distance. How much is the total distance here? See here, how much is this? 300 by total time. See, what is the time he taken? That is 2 minutes 30 seconds. 1 minute 60 seconds. You know it. So 2 minutes is 2 into 60. How much it will be? It will be 120 plus 30. How much? 150. So that is equal to 300 by 150. That is 2 meter per second. This is the average speed. Now he travels from A to B along a straight path. So his average velocity also same. That is average velocity also, because there is no change in direction. It is along a straight line. Now average speed and average acceleration both will be the same 2 meter per second. Now we want to find out the average speed from A to C when he jogs. That means at first he jog from A to B 300 meter. Then returns to C, that is 100 meter. Then total distance, that is V average, that is average speed. That is equal to total distance. How much it will be? You add 300 plus 100. How much you will get? That will be 400. Why? What is the time? Here 2 minutes 30 seconds from A to B. And from B to C 1 minute. Total time taken 3 minutes 30 seconds. That means 200 seconds. Now we simplify. That means all 0 we cancel from up and down. Then what we getting? 40 by 21. Now we can divide this 40 with 21. 1 times 21. Remaining 19. Putting decimal. 190. How many times? That is 9 times 9 times 1 9. 9 times 2 18. That is 9. 189. Now we can put this 9 here and subtracting 1. Then again putting 0. Here it is not possible. If we want to repeat, we want to give again 0. So it we can take as 1.90. That is the average speed. That is 1.90 meter per second. Meter per second. Now we want to find out the average velocity. Average velocity. Now we are going to find out average velocity. Average velocity, total displacement, C, A to B, now to C. The initial point A, final point is C. From this 300 meter less. So here remains only 200 meter. Total displacement 200 meter. Time taken from A to B and to return C, that is how much it is taken? That is taken as 200 time. 200 time. That is total displacement by total time. Now on 0 we can cancel, then 20 by 21. You know how to divide 20 divided by 21. In 20, 21 is not possible. So we can put a decimal in 200. 9 times, that is 9 times 1 is 9 and 9 times 2 18. So it will come as 1. Here balance is on. So 11. Put on 0. It will come. That is 5. So average velocity is 0.95 meter per second. Meter per second. Now we got at first from A to B average speed 2 meter per second. Their average velocity also 2 meter per second because it is along straight line. Now A to C, average velocity and average speed both are different because here the distance and the displacement not the same. Now we can go to, this is the answer for second question. Now we can go to the third question. Question number 3. Abdul, while driving to school, computes the average speed his trip is to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? That means Abdul, when going to school, he run his way to 20 km per hour, returns 30 km. Now we want to find out the average speed. We know average speed, that means initial speed plus final speed by 2. In that way we can find out. But here see, it is not uniformly accelerated in this case. Hence, if it is uniform acceleration, then we can take it that way. Here time taken we can find out. Let x be the distance from his house to school and return distance also same. So time we can find out at the first stage. Time t is equal to distance by speed, that is 20 when he goes to school, and when he returns, that is his time taken is equal to, that is x by 30. That means distance by speed gives time. Here also distance x itself, time, to get the time we divide with the speed. Now up and downs time we got. Now we can find out average speed. Average speed equal to total distance, that is x, one side, and return x, that is 2x, by total time. First time x by 20 plus return time x by 30. So this will simplify. See here, that is equal to 2x by, we can cross multiply this 30x plus this 20x by 20 into 30. Now see, this number is divided with a fraction, so we can take a reciprocal. That is equal to, that is average speed. V average is equal to this 2x into this denominator side come up, that is 20 into 30 by 30x plus 20x, that is 50x. This x and x we can cancel. Now with this, when we cancel 2 and 50 we cancel, we get 25. Now this 25, 5 times 5 25, here 6 times 7. This 5, when we cancel with this 4. So we get as 4 into 6, 24 kilometer per hour is the average speed. 24 kilometer per hour is the average speed of Abdul. Okay, now this is the answer for question number 3. Now we can go to question number 4. Question number 4. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meters per second square for 8 seconds. How far does the boat travel during this time? A motorboat starting from rest. Starting from rest. Then what will be its initial velocity? Say, how much will be its initial velocity? U is equal to how much? It will be 0 meter per second. Then accelerates in a straight line at a constant rate. Which letter is used to represent acceleration? Which is? We know it as A. So A is equal to 3 meter per second square. Then how long it took for 8 seconds. So time t is equal to 8.0 second. Now how far does boat travel during this time? Within this time the boat travels how far? That we want to find out. We know to find the position, that is displacement S is equal to, here we know, yes, we want to find out here initial velocity given, time is given, acceleration is given, then we can, but position time relation S equal to ut plus half a t square can be used. Here again S equal to, what is the value of u? U is 0 into t, it is 8 plus this half here we can put into a, acceleration given 3 into t square, here t is 8, so 8 square. Now see this 0 into 8 is 0 itself, that we want to add to this one. If we add 0 to this one, there is no change, so we can leave that. Then what will remain here? Half into 3 into 8 square. 8 square is 64. Now we can cancel this 2 and 64. In 3, how many times 6? How many times there? 3 times and in 4, 2 times. So 32. Now 3 into 2, 6. 3 times 3, 9. So 96 meter. The boat travels 96 meter. This is the we getting. This is the answer for which question? Fourth question. Now we got answer for fourth question. How far the water travels. Now see question number 5. Question number 5. A driver of a car traveling at 52 km per hour applies the brake and accelerates uniformly in the opposite direction. That means he is traveling at 52 km per hour, accelerating, brakes applying, so accelerating in the opposite direction. So A is negative. Uniformly in the opposite direction. The car stops in 5 seconds. That means within 5 seconds the car stops. Another car going at 3 km per hour. 3 km per hour. Applies brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graph for the two cars. Which of the two cars travels farther after the brake were applied? Among these, which will apply farther? That is, you want to draw that means speed and time graph of these two, and then you can find out this one will take that means this one will travel more because its speed is more, so more speed is coming, so this will take more distance to more, it will travels more distance before comes to rest, that you get by drawing the graph. Okay, now question number 6. Here is a graph is given. See the graph? Here the graph in the x-axis 0 to 4, 0.4 is given as 1, 2, 3, 4, 5 lines, and here 0 to 4 that is given as 7 line, and 3 graphs are here given. See 3 graphs. First that is here is given A, and then B and C. 3 graphs given, and related to this questions given, and the first one is which of the 3 is traveling the fastest. When we observe the graphs, you see within short time this B reached at first. That means more distance traveled by B at first, so with less time. So which of the three traveling the fastest means B is the answer for question A. That is 6A. Answer is B. Now second question is are all the ever at the same point on the road? That means here if A, B and C they all come together at the same time in a road, that answer is no, because by observing graph that answer we got as no. Then question C here given, how far has C travelled when B passes A? That means how far has C travelled when B passes A? B passing, see here, B and C is passing at this point. Then the C is here. C is here means nearly, that means not reaching 8 kilometers, so we can take it approximately 7 kilometers. It is 7 kilometers. Then another question given D, that is how far has B travelled by the time it passes C? That means how far B travelled by the time it passes C. B and C passing here. See B here and C here. These two passing at this point. This point B and C passing. So its answer is nearly that comes 5.4 kilometer. By observing the graph, we will get it as answer. By observing the graph, we will get its answer as 5.4 kilometer. Okay, this is the answer for the question number 6. Now comes to question number 7. A ball is generally dropped from a height of 20 meter. Its velocity increases uniformly at the rate of 10 meter per second. With what velocity will it strike the ground? After what time will it strike the ground? A ball is generally dropped from a height of 20. That means here S or H is equal to 20 meter height. Then its velocity increase uniformly at the rate of, that means velocity increase uniformly at the rate means accelerating 10 meter per second square. Then see with what velocity will it strike the ground? After what time will it strike the ground? See, two things we want to find out. What is the velocity with which it strike the ground, and what is the time taken to reach the ground? These two things we want to find. See, here given the body is dropped from rest, so its initial velocity u is equal to 0. Now we know S A, that is A we can take as A also, u is equal to 0. From the relation S equal to u t plus half a t square, we can find a t. That is S, how much is coming? S is 20. U is 0 into t time we don't know. T itself plus half into A is how much? A is 10 into t square. So here from this relation we can find t square. That means 20 is equal to 0 to t, and then we can leave then this by simplifying we get a 5 t square. So t square is equal to 20 by 5, that is equal to 4. So t is equal to root of 4. Root 4 is equal to 2. That the time taken is 2 seconds. Time taken to reach the ground is 2 seconds. Then we want to find out its velocity when it strikes the ground. By using this relation, V is equal to u plus a t. See, we don't know. V is equal to u0 plus a 10 into t. That is 2. That is V is equal to 10 into 2, 20 meter per second. That is the velocity with which that body strikes the ground. The velocity with which the body strikes the ground is equal to 20 meter per second. Now, another graph is there given. See the graph. Here the graph shown is not uniformly accelerating. Here the graph is not uniformly accelerating. If it is uniformly accelerated, then the graph is a straight line. Here the graph is not a uniform accelerated body. So, we cannot directly find out length and breadth to get area. So, the question is that the speed time graph of a car is given. Speed time graph of a car is given. Find how far does the car travel in the first 4 seconds. Shade the area on the graph and represent the distance traveled by the car during the period. That means in the first 4 seconds, here it is coming. This region we want to shade. Here when we count, we cannot find directly area of this graph, so we count in these small columns. When we count, we get nearly 64 columns in this. That means when we count this one, we get somewhat when we count full columns and half columns together, we get 62 square columns, 62 square columns from this. And by putting C in this here speed is 3 columns, 2 is given, so 1 column is equal to how much? 2 by 3. Similarly here also, by simplifying, we get this on as 16.53 meter. How much? 16.53 meter is traveling within 4 seconds. By calculating the area of these columns, we get the distance traveled is equal to 16.53. And another question, which part of the graph represents uniform motion? That means, see, from 6th second onwards, the graph is parallel to time axis. That is, its speed is not changing. So, it is uniform speed is starting from 6th second onwards. 6th second onwards, its uniform motion is starting. That means after 6th second, the graph becomes parallel to the time axis. So, first question number 8, answer A is 16.53 meter and its speed is how much? It is from 6th second onwards. It's travels with the uniform speed. Now question number 9 to 1. Question number 9 to 1. State which of the following situations are possible and give an example for each of these. State which of the following situations are possible and give an example for each of these. An object with a constant acceleration but with zero velocity. First question is that is 9th A. An object with a constant acceleration but zero velocity. That means there is acceleration but velocity is zero. Suppose when we throw a stone in the upward direction. See, when a stone is moving upward direction, velocity is gradually increasing, but there is acceleration. That is 10 meter per second square in the downward. When the stone reaching the maximum height here, that means velocity here becomes what is the velocity here? It is 0. But then also there is acceleration. So when a stone is thrown upward, there is acceleration and velocity. When the stone reaches at the topmost point, there is acceleration but velocity is 0. The acceleration is there, but the velocity, when the stone starts to come from the maximum height, at that time there is acceleration but velocity is 0. and it should be an object is moving in an certain direction with an acceleration is perpendicular to the direction. See, an object is in circular motion. See, here the direction of velocity is here, but the acceleration is towards its center. In this case, acceleration and velocity, here see the speed, when we count speed means without there is no direction. Here the speed of this or velocity in this direction, but acceleration is here. So here they are perpendicular. They are perpendicular. An object is moving in certain direction with an acceleration in a perpendicular direction. Here is an example. When a body is in circular motion, acceleration is perpendicular to the direction of motion. Now question number 10th one, an artificial satellite. An artificial satellite is moving in circular orbit of radius 42,250 km. That is radius is given 42,250 km. Calculate its speed if it takes 24 hours to revolve around the 24 hours to revolve. Then we want to find its speed. We know that its radius is how much? 42,250 km. So to go once around, that is this way. If it is going round, suppose it is started, this is the radius, and it is given as 42,250 km. And when suppose it starts from A and this way it moves and again comes to this, here it is coming. The time taken for this traveling 24 hours. So speed is equal to, we know, distance by time. Speed equal to distance by time. So S equal to distance here 2 pi r divided by speed. We can take as V. Speed is equal to distance by time. That is 2 pi r divided by 2 pi r divided by time. T, that is equal to 2 into pi, 3.14 into r, 42,250. This we can convert into kilometer. Kilometer is by multiplying with 1,000. And time is 24 hours. That is 24 into hours to change 1 hour is 60 minutes and again into 60 seconds. And when you simplify this all together, we get 3071 meter per second. By solving this relation, you get the answer as that is this all quantities multiplied and divide with this, then you get its value as 3071 meter per second as its speed. Okay student, we solved all the exercise problems and questions. If you have any doubt when you go through this, you ask to me and with this we can wind up today's class. Okay.